Next question. Find the sum of all integers between 100 to 400 that are divisible by 7. Okay, let's look at the first number that is greater than 100 and is divisible by 7. So I'm going to do 100 divided by 7 in my calculator at the side, and it's giving me 14.2. So then what is 7 times 15? That should be the first number that's divisible by 7. It gives 105. So the first value of this sequence is 105. Then when we plus 7, we get 112. Then plus 7, we get 119, and so on. And now I need a number which will be the last number of the sequence, and it has to be smaller than 400 and divisible by 7. So on the side again, I'm going to do 400 divided by 7. That gives me 57.14. So now I'm going to do 7 into 57. That's going to give me this number. It's 399. So the last number of this sequence is 399. We know what A is, 105. We also know that this is an arithmetic progression because 7 is being added. So D is 7. Okay. They're asking for the sum of all integers between 105 and 399. So we need Sn. We don't know what n is yet. And since we know the last term, so I'm going to recommend let's use this formula, n over 2, a plus the last term. Okay, so now we need the value of n. That's supposed to be plus. Okay, so how do we find the value of n? We know that this is the first term, right? This is the second term, this is the third term, but which term is this? So one way of doing that is that you use the nth term formula, which is for an AP, it's a plus d times n minus 1. So a is 105, d is 7 times n minus 1, and the nth term whose n we're trying to find is 399. So now you rearrange, move everything around and get the value of n. It's going to be 399 minus 105. Then I'm going to divide with 7, and 399 minus 105 divide with 7 and plus 1 to the answer. I'm getting n equals 43. So that means 399 is the 43rd term. So now that all that is left to do is substitute the values. 43 over 2 times 105 plus the last term 399, which gives 10836, which is the answer for the first part, part A. Okay. Part B says, first three terms of a GP are 144, x, and 64 respectively, where x is positive. Find the value of x. Okay, so we know how to connect three consecutive terms of a geometric progression. The rule is third term divided by second term should give you the same answer as second term divided by the first term. So this divided by this equals this divided by this. Okay, so cross multiply, we get x squared here, and we get 9216 here. Square root both the sides, we get x equals plus minus 96. But the question says x is positive, so you have to use the positive x only, 96 only. Okay, part 1 is done. Part 2 is find the sum to infinity of the progression. So sum to infinity is this a upon 1 minus r. We know what a of this progression is. It's 144 from here. Now we need r. So we know the first term is 144. We also know x. The second term is 96. The third term is 64. So R is any term divided by its previous term. Simplify this, 96 over 144 comes out to be 2/3. So R is 2/3. Substitute it here, 1 minus 2/3. We get 432, which is the answer.